me ask you a question. What does a lava lamp, an empty 2-liter bottle, and a bird have in common? Well, not all birds, but this kind of bird. That's what I want to talk about. Hi, I'm Justin Berk. I'm a meteorologist, I'm an educator, and I'm a dad. And like many of you, during this COVID-19 state of emergency shutdown, I'm relegated in my house with my family. That brought a lot of businesses to a grinding halt, and I do a lot of education programs. I visit about 50 or 60 schools a year, elementary, middle school, STEM-based weather programs that I can't get to. So I figured, why not use what I have at my disposal? I even spent 10 years as an adjunct professor for Stevenson University, starting way back when they were Villa Julie College. So I have a lot of stuff that I used to do in the classroom. I love hands-on demonstrations because it's a really good way to get an idea of how stuff works in the world, especially in weather. So that is my plan. So today, let's start with this first topic. And it all begins with the lava lamp. Now, I'm a child of the 70s. That's not why I have one. And to be honest, I bought this thing for a science demonstration because this is one of the best ways to conceptualize the topic of thermals. Something we experience every single day. So let's take a look at it. What is a lava lamp and how does it work? Have you ever taken a close look at a lava lamp? I mean like a really long, close look with some music in a dark room. Well, if not, I got you covered. I've moved my lava lamp to the back here, turned the lights off so we can check out how this thing actually behaves. And it's very simple with these bubbles of goo moving up and down. This is glass, and inside we've got a clear fluid, and we've got another denser one with a higher viscosity that responds to the heat. So let me get my safety oven mitts on. I'm going to pull this off and show you that underneath is a light bulb. It's that simple. It's hot to touch, and it provides heat for this environment. We've got a closed environment here. We've got an environment where this bulb is providing heat at the bottom. And once that bubble gets enough heat, it is actually going to lift up. And let's get around over here. And sometimes it does interact with some of those other bubbles. There we go. And now that it's got a fresh source of heat, it is going to rise to the very top. And the very top under this cap literally just lets that thing cool off. And once the other bubbles cool off, they will sink back down. It's that simple. Hot bubbles rise and cold bubbles sink. We have now created a convective system. It's convection. These rising bubbles are thermals. They got heat, they rise up, and the cool stuff sinks back down. It's a continuous motion that will continue as long as we provide that unequal heat source. And it is exactly what happens outside almost every single day. So let's go to some of my old weather graphics and check that out. On a typical day, the sunlight is sending energy down to the surface of the earth. And that surface is what absorbs the energy and converts it to heat. That's really how we heat up. It is not directly from the sun, but it's indirectly as a result of what is on the ground absorbing that solar radiation. And whatever absorbs more and gets hotter is going to create those warm rising bubbles. Those warm air bubbles rise up, and they don't move in a straight line. They have twists and turns and vortices, but they do go up as a complete bubble system, and it's those thermal bubbles that we can see in a response in the world around us. Now, one thing we can see sometimes if there's enough moisture, that it gets high enough and it will cool and condense and we'll start forming clouds. The clouds that form from this are the cotton ball clouds that are called cumulus and can eventually, if enough energy, build up into a thunderstorm. But it's outside that I really wanted to show you these birds. I live on a steep hill that gets unequal heating because of the slope and interaction with the sunlight. So there are thermals here almost every day. And I've got plenty of these ginormous turkey vultures. They are huge birds, and it takes a lot of energy for them to flop their wings and get up in the air. However, once they're up there, they know how to find these thermal bubbles, and they catch them, and they ride them. And it is amazing. They just hold their wings out, and often will circulate, and they can stay afloat for a really long period of time without exerting much energy. All right, so what can you do back inside? Well, check this out.
Remember that bottle I talked about at the beginning? All right, here's where it's going to come in handy. And if you got kids, you're going to be amazed by the response that they get when you show them that they can create a thermal and have convection right there in the palm of their hands. All right, it's going to take a 2-liter bottle, empty of it, all the liquid inside. I really like the clear bottle because then you can see on the other side and you strip the label off. Now, the bottle itself is going to just need a balloon. You may not have a latex balloon handy, so if you can still get to the store, this may be one of those extra items you might want to have. There's other fun stuff you could do with the kids that's not even weather related. Now, we're going to put this thing inside the refrigerator for 10 to 20 minutes. That is going to allow the air to cool down into the upper 30s inside. The balloon is going to cap the air inside that bottle. Now, at room temperature, it's about 72 degrees in here. Compared to my 98-degree hands, there's not going to be much difference. So you really want to cool this bottle down first before we cap it. And I'm going to do that for about 10 to 20 minutes. We'll come back in a moment and we'll see the difference in what this bottle does. About 20 minutes inside the refrigerator, we've trapped 37-degree air inside that bottle, capped it with a balloon. 98-degree hands. And all we do is gently touch the bottle. You can leave it on the table. You can pick it up. You don't have to squeeze it. It is going to do its thing naturally. Just by touching this bottle, you are transferring heat by a process called conduction, which is just by touch. You're warming up the bottle. Then the air on the inside warms up and boom, we have got ourselves a thermal. See you go. No squeezing. That is just pure convection right there in your hands. And if you do this for your kids, their minds are just going to be amazed and you're going to be a rock star. All right, I hope you enjoyed this video. If you like it, please let me know. If you've got any comments, please share them. If you got any questions, if you got any ideas for a weather topic that I might be able to talk about, let me know. We are crossing a threshold today. While we may be in this new norm with our families inside, we are just about to enter the spring season and we have more daylight than darkness. That may enlighten your spirit, and if we can keep a sense of calm and keep the minds active, maybe we can explore a little bit more of what is outside, get those kids' imaginations going, and perhaps they'll come up with some cool experiments or demonstrations and teach us. I'd love to see that. And if you get that on video, I promise you I will share it. Thank you all so much, and make sure you share this with your friends and your families. And I will be providing some additional educational materials throughout the week and the weeks ahead for the little ones to maybe do some activity sheets and learn a little bit about the weather. All right, so thank you all so much. It's about thermals and it's about convection, and it's about time for me to call it quits. See ya.